This is lesson 1.3, distance and midpoints. Your objectives are to find the distance between 2 points and to find the midpoint of a segment. To find distance on a number line, you take the values of the 2 points and subtract them and then take the absolute value. Always subtract for distance. And on the coordinate plane, you use this formula. Notice again the subtraction, the squares, and everything is under the square root. Use the number line to find each measure. Segment BD. Well, B is between -8 and -6, so it's at -7. D is at -1, so we will subtract and take the absolute value. -7 minus -1 is -6, and the absolute value of -6 is 6. Number 3, the measure of segment AF. A is at -9, F is at 3. Do the absolute value. 3 minus -9, that's the absolute value of 12, which is 12. The distance does not matter the order that you're subtracting. You could do 3 minus -9 or -9 minus 3. You will still get 12 after you take the absolute value. Find the distance between each pair of points. For the points 0, 0, and 6, 8, feel free to label the first point x1, y1 and the second one x2, y2, and we'll substitute the numbers in where they go. x2 minus x1 and y2 minus y1. 6 minus 0 is 6, squared is 36. 8 minus 0 is 8, squared is 64. That's the square root of 100, which is 10. For number 10, -2, 3 is your x1, y1. 315 is your x2, y2. So we will substitute the values in where they go. x2 minus x1 and y2 minus y1. 3 minus -2 is 5, squared is 25. 15 minus 3 is 12, squared is 144. That's the square root of 169, which is 13. Substitute your numbers in and work it out. Midpoint of a segment. The midpoint on a number line, you take the coordinates, add them together, and divide by 2. On the coordinate plane, the midpoint is found by adding the x's and dividing by 2, and adding the y's and dividing by 2. Your answer for each of these is a point. It is the midpoint, the point in the middle of the segment. Use the number line to find the coordinate of the midpoint of each segment. For segment CE, we're going to use -4 and 2. Add the numbers and divide by 2. That's -2 over 2, which is -1. Number 2, the midpoint of segment DG. D uses 0, G uses 8. The midpoint is found by adding those numbers and dividing by 2. That's 8 over 2, which is 4. 4 is the midpoint. Find the coordinates of the midpoint of a segment with the given endpoints. On the coordinate plane, we use the midpoint formula, so substitute your values in. 0, 0 is x1, y1, 12/8 is x2, y2. So it will be 0 plus 12 over 2 to add the x's and divide by 2, and then y1 plus y2 over 2. 0 plus 12 is 12, divided by 2 is 6. 0 plus 8 is 8, divided by 2 is 4. The midpoint is 6, 4. It is written like a point in parentheses, like an ordered pair. For number 10, negative 12/8 is x1, y1. 6/12 is x2, y2. Put the numbers in the midpoint formula. x1 plus x2 over 2, comma, y1 plus y2 over 2. Negative 12 plus 6 is negative 6. Divided by 2 is negative 3. 8 plus 12 is 20. Divided by 2 is 10. Negative 310 is the midpoint. Let's look at 3 more questions. Up until now, we were given the 2 endpoints, find the midpoint. Now, we're given 1 endpoint and the midpoint, find the other endpoint. If you know 1 endpoint and the midpoint, it's very easy to do, and you don't even need the midpoint formula. Look at the x values. From 2 to 5, you added 3. The midpoint is the exact middle of this segment, which means you have to add another 3 to get to the next x value, making it 8. Look at the y's. From 0 to 2, you're adding 2. Well, add 2 more to get 4. So 8, 4 is your other endpoint. Find the distance apart from the x's and the y's and go that same distance again to the other endpoint. On this question, n is 1 endpoint, p is the midpoint. How do you find the other endpoint? Well, look at the x's. From 5 to 6, you're adding 1. P is in the middle, which means it's the same distance on the other side. Add 1 again, and you get 7. For the y's, from 4 to 3, you're subtracting 1. Well, subtract 1 again to get 2. So 7, 2 is the other endpoint. For the last one, P is the midpoint, N and Q are the endpoints. Look at the x values. From 3 to negative 1, you're subtracting 4. Subtract 4 more, and you get negative 5. Look at y. From 9 to 5, you're subtracting 4. Subtract 4 more to get 1. Negative 5, 1 is the other endpoint. Just remember, for all of these, use the correct formula. Make sure you know whether you're on the number line or in the coordinate plane, using the proper distance or midpoint formula. Remember that in the distance formula you subtract, in the midpoint you add. And when you have a problem like these last 3, it's easiest if you find the distance from one end to the middle and go that same distance from the middle to the other end. This is lesson 3.3, slopes of lines. Your objectives are to find slopes of lines and to use slopes to find parallel and perpendicular lines. The slope m of a line containing 2 points with coordinates x1, y1 and x2, y2 is given by the formula m equals y2 minus y1 over x2 minus x1, where x1 is not equal to x2.
Just remember, those 2's and 1's are not exponents or any number to do arithmetic with. That just means the first x and the second x, and the first y and the second y. We'll substitute our numbers in and find the slope. Find the slope of each line. For line P, the point 1, 2 is your x1, y1, and the point -2, -2 is your x2, y2. So in the formula, y2 minus y1 will be -2 minus 2. x2 minus x1 will be -2 minus 1. And that's -4 over -3, which is 4/3. Leave your answer improper. Don't make it a decimal. Keep it as a fraction. If it reduces to an integer, then make it an integer, but never make it a mixed number. For line Q, 2, 0 will be x1, y1, and -3, 2 will be x2, y2. Now, can we change those and say that 2, 0 is really the second point and -3, 2 is really the first point? Yes, you can. It doesn't matter which point you choose to be the first point and which to be the second point. Just set it up and then keep it that way as you work out the problem. y2 minus y1 is 2 minus 0. x2 minus x1 is -3 minus 2. That's 2 over -5, which is -2/5. Now when you're finding slope, remember that if the slope is positive, the line will be slanting upward left to right. If it's negative, it will go downward left to right. If it's a slope of 0, it's horizontal. An undefined slope is vertical. Undefined is when the denominator is 0. So it's a good way to check your answer. If your slope is negative, it should tip down, like line Q. Line P had a positive slope, and it slants upward. Number 3. Find the slope. y2 is 3 minus y1 is -2 over x2 is -6 minus x1 is 1. Substitute the values right into the formula. 3 minus -2 is really 3 plus 2, which is 5. -6 minus 1 is -7. And that's -5/7. Find the slope of each line. Number 7, line AB. Well, when the line is drawn for you in a picture, it's sometimes fastest to use this version of the slope formula. M equals rise over run. Rise is the distance up or down, and run is the distance left or right. So pick 2 points on the line and calculate how much of a rise it was over how much of a run it was. For line AB, I can use points A and B. The rise from A to B is up 6. The run is over 2. So rise over run is 6 over 2. And that's a 3. Rise is vertical. If it's up, it's positive. If it's down, it's negative. Run is horizontal. If it's right, it's positive. If it's left, it's negative. And then make sure it's reduced. Line EM, that's a vertical line. From E to M, that's a rise of 4. But you don't run any. You don't go left or right because you can't, because it's vertical. So the run is 0. And 4 divided by 0, that's undefined. Remember, a vertical line has an undefined slope. When you divide by 0, it's undefined. Remember, when the 0 is under, it's undefined. Under, undefined. That's how you remember.